Hi everyone, welcome to part 11 and for now the final part of the Azure Masterclass. And this is all about infrastructure as code, thinking about using Git for version change control, and then actually DevOps, in this case using GitHub and GitHub Actions. As always, if this is useful, please go ahead and give this video a like, go ahead and comment, subscribe and share. So first off, we have the Azure Portal, we have PowerShell, we have the AZ CLI. So why are we bothering with infrastructure as code at all? Because they are great options. And actually, something I want to kind of stress at the point, we're going to cover a lot of stuff in this video. I've put more than usual in the repo for this, so you can kind of follow along. So as I talk about things like PowerShell and CLI, that's not infrastructure as code, that's not my focus for this at all. So I'm going to spend literally seconds on it. But in the GitHub repo, I've got some commands you can kind of look at and work out a little bit more kind of what's going on, just for your own kind of learning. So we have the portal, and the portal was great. I mean, if I jump over for a second, if we go and look at the Azure Portal, it's super intuitive. I can easily go and see, well, hey, what, for example, is the configuration of a storage account? I can select it, I can see basic information, I can look at the detailed configuration, I can see the options. We even have things like Storage Explorer integrated in to go and evaluate. Hey, if I'm trying to experiment with a new resource, well, I can go ahead and create a resource. Sure, I'll create a Windows Server 2016. I can see all the types of options available to me. It's super intuitive, it's super friendly. It's kind of slow. If you think about going through every single page of this wizard to create the resource, but it is really kind of friendly. I can go in and see the state. It's useful from that perspective, but it doesn't scale. Like trying to create a lot of resources is super, super slow. But to go and learn to see what's possible, I can create great dashboards. Portal's good for that from a visualization perspective. We have PowerShell. We actually have an AZ module, which is kind of a meta module made up of lots of smaller modules that really works through the REST API for ARM, Azure Resource Manager, just like the portal. There's also the AZ CLI, and both of these I can install locally on my machine. Gives me a huge range of capabilities. So if again we quickly kind of jump over, this time I'm going to look at VS Code. So in here in VS Code, what I'm actually going to do is, let's take a second, and this is the repo for this course. And so I've got this kind of local copy of everything in here. I'm going to open this demo script. So in here I walk through, well, how I can actually install the AZ module. So this is the PowerShell. Now remember, even the PowerShell and the CLI, they're cross-platform, Windows, Linux, Mac OS. So this is a way to install it for all users. I can check the version I have available, for example. Here we can see at the bottom, well, my AZ module, it's version 5. And you can also see it's kind of cross-platform by that PS edition. It supports core and desktop. So now it's going to be available cross-platform. So I can install PowerShell 7, for example. It used to be called PowerShell kind of core in 6, but now it's just PowerShell. It's all kind of come together. So I can have PowerShell 7. I can install the AZ module. We have things like contexts over both PowerShell and CLI. So I might have multiple subscriptions under my identity. I can easily switch between them. Again, not going into that in this course. I'm about to record a video on PowerShell for Azure. I did one years ago. It's a little bit out of date now, so I'm going to update it and I'll go through all of this stuff. But I can do things like, well, I could look at all of my resource groups. I could look at all of my virtual machines where, for example, the state is not running. You can see me running these commands at the bottom. I can look at secrets, extensions, look at all the different images that are available, create virtual machines, deploy templates, huge amounts of things. Then we get to the AZ CLI. Now I have that installed on this same box. I can do the same types of thing. In fact, this time I'm just going to say, well, let's look at all of the locations. So this will show me all of the locations available in the environment. I could look at all the virtual machine sizes available in East US 2. I can output to a table to make it easier for me to read. And I can do the same types of things I could do with PowerShell. Hey, show me all the ones that are running with an AZ command. Notice I'm changing some of the output to just show me kind of 4 columns. And I'm naming, well, I'm giving it a friendly name of region instead of the base location attribute name. So I can modify all of these things. And this is great. And it's super powerful. And definitely, if I think about, hey, I want to do some maybe management actions using the PowerShell, using the CLI is phenomenal for that. In fact, we even have, yes, I can install it on my machine. The Azure module, the Azure CLI, I can run those locally. Again, Windows, Linux, Mac OS. But in the portal, it actually has something called Cloud Shell. And I can even, that's basically a container. I could run it integrated with a virtual network to get to other resources in Azure. I can even kind of run that locally. But a really easy way to get to that, the Cloud Shell is actually integrated with the portal. So if I ever find myself somewhere where, hey, look, I don't have my machine handy, up here in the top, you can kind of see this shell icon window. If I click that, what it's actually going to do is use an Azure storage account. It's going to create a file share in there where it's going to store my profile. Now I can run this as both a PowerShell version and Bash. So I can flip between them depending on what I want. But again, PowerShell and the AZ CLI is cross-platform. So I can use them in either one. It really comes down to, well, what types of scripts might I want to run? And behind the scenes, what Azure's actually doing is creating a container to host this session. Also, what might drive me for PowerShell actually has a Azure Drive, a provider that makes me see my Azure content actually just directly like it was a file system. From here, I could go and look at resources. I could look at maybe my resource groups, list, output table. Again, it's cross-platform, so I can run both AZ and the PowerShell. I can also, instead of running it from within kind of the main portal.azure.com, I can actually go to shell.azure.com. I would select the tenant I actually want to run this as, my Saviltech. And now I just have a full shell window. And I could, again, do all the same types of things. I can pick between PowerShell and CLI. Even things like the local Azure app. I can utilize this with and actually go and get a shell. So super easy to quickly get access to things. So great, we have these options. Why do I need anything else? So they're all imperative. Yes, they're all cross-platform, but it's that imperative nature that makes it problematic from a resource provisioning, creating resources. What I mean by that is, it's hard to check what's already deployed. Yes, I can write a great PowerShell script or CLI script to create resources. If it fails halfway through, how does it know what's been created already and how to maybe go and check? Also, what if I change it? What if I want to change a configuration? Well, in my script, I now have to write a bunch of different commands to modify rather than create, because I'm telling it how to do something. Imperative is all about how to do something. I can kind of think about it if I was driving somewhere. Imperatively, I would say, well, you go 100 yards, then turn left, then drive 300 yards, then turn right, etc. Now, if I started at a different place, those instructions wouldn't work anymore. I'd have to change that. Whereas another option would be like, hey, I just want to be at this location, you deal with that. And as I mentioned, we have the Cloud Shell. So the other option is declarative. And this is all about Jean-Luc Picard, make it so #1. And when Jean-Luc Picard would say, I want to be a gamma, 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 quadrant 2, make it so. He didn't worry about, well, take the ship out of neutral and then warm up the engine and then, hey, turn left a little bit and then at the second moon of blah, 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 go right 45 degrees. He didn't do any of that. He was just like, number one, make it so. And then the rest of the crew of the Enterprise, their job was to work out how to make the captain's desired end state, being at whatever I just said, gamma, gamma, blah, blah, blah. How do they make that reality? So they would work out what are the steps they have to perform to translate the desired end state into reality. So the ship's crew kind of was that engine. When I think about computer systems, we state only the desired end state. So if I think about provisioning resources, I would just say, well, I want a storage account. I want it in central US. I want it to be LRS of type storage general purpose V2. That's it. I'm not worrying about if it already exists, but it's a different configuration. I'm not worrying about if it doesn't exist. I want it to be this way. Go and work out how to make that so. So that's the point of a declarative technology. I never have to worry about current state. I just say, I want it to look like this. So now I can have one file with my desired state in it. And whether I'm changing that file with a slight configuration tweak or it's brand new, nothing changes on my side. This is my desired state. I might change my desired state. Not my problem how to make that reality. It's the technology's problem how to make it reality. The other great thing about using a declarative technology is if I think about it, often we have requirements that say, well, is that still the configuration? Has there been drift? Are you still meeting the policy required? So if I state a desired end state with declarative, well, it's easy to check. I have written down what my desired end state should be. I have what's deployed. Do they match or is there drift? If there's drift, what's the drift? So that's a huge benefit with declarative technologies. So it's easy to modify. I can just change my desired end state. It's easy to track what has kind of changed with these. And it's completely prescriptive. I can take this desired end state and I can say, do the desired end state to dev, to user acceptance test, to production. It's completely declarative in that it's always going to be the same. It's never going to change anything about that. So it's an absolute. If I try and create things from the portal, well, A, it's super slow, but how do I know I did the same steps between dev and user acceptance test and production? It's almost impossible to do that. So I get drift. Now with PowerShell and CLI, I have a script. It should be the same. There shouldn't be drift. But with PowerShell and CLI, can I say, well, what's deployed matches the script? The script said, hey, create VM, then add this extension, then run these commands and do. How can I tell? I have to kind of walk through what would this have done, and it's very hard to detect drift with an imperative technology, saying how to do something. Same as Jean-Luc Picard. If Jean-Luc Picard was saying imperatively, well, I want you to go 5 light years that way and then turn 50 degrees and then go 2 light years, how would he know those steps were followed? He'd have to try and work out, well, where did I start? And okay, if I track that way and then turn that way, would I be here? Whereas with his declarative technology, I want to be at gamma, gamma, blur. To see if there's drift, he says, well, am I at gamma, gamma, blur? That's it. Doesn't matter how he got there. My desired state was this. Am I at my desired state? So it's easy to detect drift with that type of technology. I have full version control. I mean, it's a desired end state. It's as a document type. In this case, with Azure, it's JSON. Other technologies might use different formats. YAML, yet another markup language. It can vary, but it's readable. And I can easily source control that. Now I can do that with a PowerShell script with CLI as well. I can track those things in version control, and absolutely I should. But the great thing about these kind of declarative technologies, it's super easy in that source control because it's desired state. See, oh, that attribute's changed. My desired end state changed between these things. Now, I can use declarative technologies to provision the Azure Resource Manager resource, create a storage account, create a VM. And there is Azure's native technology, Azure Resource Manager templates, which we're going to focus on. But there's third-party ones. There's things like Terraform. Terraform is super powerful. The benefit Terraform has, there's a number of benefits. Terraform is nicer to look at and author. One of the pain points with ARM is very verbose. It's not that friendly to look at. Terraform also has providers, yes, for Azure, but for AWS, for Google Cloud, for Kubernetes, for VMware. It can deploy across different environments in a very consistent fashion. Through these providers it has. Now, the only downside with Terraform from that perspective is because it supports all these different types of clouds, for it to work out, well, is the end state matching, it has its own state store, and that's what it uses to compare against. So I do a plan, which works out my desired state versus what's there according to this state, and then I can apply. We have to be careful with that state. If I change something outside of Terraform, the state file is out of date and doesn't know about it. And then it gets very confused. If I have multiple people deploying to the same environment, they need a shared state file. I have to put it somewhere, which I can do, put it in blob storage, for example. I have to put it somewhere they can all get to. So there are third parties. I can then think about solutions inside the resource. So sure, I could use ARM to deploy the Azure resource, but maybe I then want a declarative technology to configure the internal resource. Maybe it's my Kubernetes deployment of pods. They have the deployment YAML files, for example. Maybe it's configuration of a virtual machine operating system. Then there's things like PowerShell desired state configuration. There's things like Chef, Puppet, Ansible, and more. So there's all these different technologies. My focus here, this is the Azure Masterclass, so I'm going to focus on Azure Resource Manager templates, but be aware there are other things. If I'm multi-cloud, you're probably going to be a better fit for something like Terraform. And Terraform is really tightly integrated with Azure. It's actually, the tool set is part of things like the Azure Cloud Shell. It's just there for me. So under the covers, everything in Azure is actually JSON. When I provision something from the portal, there's often an option to export. I can look at existing resources and export. So let's take a quick look at that. So if we jump over to the portal, and here, well, we're to start with looking at a resource. If I look at an existing resource, a storage account, if I scroll down all the way to the bottom, we can see there's this option, export template. And if I look at that, it's showing me the JSON to create the storage account. It shows me things like, well, there's a certain parameter that I can pass in. In this case, it's the name. So it's the name of the storage account. Likewise, if I create something brand new, I'll stick with storage accounts because they're very simple. I'm going to use storage accounts for a lot of this demo. I say, hey, let's review, and I'll give it a resource group, doesn't matter. Give it a name, doesn't matter. Review and create. Well, we see down the bottom here, well, look, download template for automation. If I go and look at that, once again, it's going to show me the JSON. Now you'll notice there's this option up here, add to library. There is a concept in the portal of a library where I can store these JSON templates. It's been in preview forever. I mean, years it's been in preview. I'm not even convinced it's going to go anywhere. It's fairly limited in what it can do and what it can access. Personally, we're going to talk about using a true repository like GitHub or Azure DevOps. I wouldn't really use it. I don't see the benefit of it. There are much, much better options. However, if you just kind of got a couple of templates and you kind of experimented, sure, there's this preview library capability that you can kind of play around with. But the key point is, under the covers, and you can even go to resources.azure.com. In fact, let me show you that quick, so that's kind of cool. If we jump over, so actually under the covers, everything here, so if I just, we'll go home for a second. If I just change and go to resources.azure.com, this is kind of peeking under the covers of Azure. And I could go and look through my subscriptions. Remember, in Azure, everything is built from resource providers. So I go and look at a certain resource group. We'll pick my South Central US. I can see it's using providers from things like storage. Then under there, hey, storage accounts, and I've got various storage accounts. And I can see the JSON. That's actually kind of the configuration of what it's doing with this resource. I can see, hey, look, the SKU, the name, the tier, all of the data underneath the covers, Azure is storing as JSON. And so the most logical way for me to actually create resources is to use JSON. Now there is a huge library of starter templates. Can I create them from scratch? Yes, I can. Do I want to? No, I don't. They're really not very friendly. Now I'm going to walk through a bit more detail of one in a second, go through what makes it up. But the easiest way to actually do this is to go and look at the quick start templates. So the quick start templates, there's a huge number of these. You'll see like 101. These are the most simple. Then there are like 201s, 301s. They get more and more complex. But what I would try and do is find a template that's similar to what I want to do. So I could see, for example, here with all these 101s, look, data factory, express route, private peering. There's huge, huge numbers of these. Anything you can think about you want to do, there's a template. And so I would take that template and start with that. Now I might need to customize it a little bit, but I can definitely start there. So here there's like a 101 VM simple Windows. If I select that, well, I can see, well, there's the actual main JSON file that defines the actual resources. So if we look at that, you can see all the different parts, and then it's actually going to create things like, well, it has a storage account, probably using the storage account for its diagnostics. Then, or in this case, it has a public IP address, so I can get to it from the internet. Terrible idea, but whatever. Then it creates an NSG. Okay, so it's going to lock it down a little bit. Then this one actually creates a virtual network with a subnet as well. Then it goes and creates a NIC. So a NIC is a separate resource. And we can see here, well, there are dependencies. The NIC requires the virtual network to exist and the public IP. So it's going to wait for those things before it creates. Now that will cause some parallelism challenges. So we only want to do depends on if we really, really need it, which it does in this case. And then finally, we kind of create the virtual machine. And that is going to utilize those other resources. You can see the VM depends on the storage account for its diagnostics and the NIC. And then we kind of configure those various things, the OS disk, the data disk, and there's that diagnostics profile that I was kind of guessing at. That uses the storage account. So there are examples of pretty much anything you want to do. So my recommendation is to go and find one that's close. You could combine things together. There's a parameters file. So we separate things that might change into a parameters file. In this case, it's the admin username, the admin password, and the DNS label prefix we're going to add to that public IP address. Now, they get more complicated. If we go down like the 201s and the 301s, it starts getting to multi-tiered services. My point is, there's huge numbers of these, and there's probably going to be something that matches what you're trying to do. Now you'll notice there was the parameters file. And the reason they have the parameters file is the whole point of what we're trying to do here is have this absolute prescriptive declarative configuration that I don't want to change. The whole point of this is I want to kind of create this JSON configuration file that deploys whatever this resource or this application spec is. And what I want to be able to do is, if I think about it, well, I might have different environments. I can think there might be kind of a dev, and just for simplicity, there might be a prod. Now, what I definitely don't want to do is I want to be able to source control these things. And I would say, well, this is template and this resource, and this is kind of the V1. And what I want to be able to do is deploy that. So I want to be able to deploy that without any changes to dev. Once that's been proven, well, I will then change it, deploy it to prod. Now, I just said change it. I don't want to change it. I should make 0 changes to the file. This is the JSON file. But there are probably going to be differences between dev and prod in terms of maybe URLs, maybe it talks to a SQL database, maybe the IP scheme of a VNet is different. So there are going to be some things that are different. So what we do, the things that might vary between maybe different environments or maybe different instances, this template might stand up a core set of resources that I want in 20 different applications. So what we also have kind of separately is we have a parameter file. Now this is still a JSON file, but this is my parameters. And this could be my param for dev. And then I can have a different param file for prod. And when I do the deployment, I can say, well, which parameter file to use. So now the actual configuration, the ARM file, doesn't change between environments or instances. The things that might vary between environments, between instances, I have their own version of a parameter file that I would pass to it as part of the deployment. So that's why we separate out a parameter file. So I can have the things that will change isolated away from the main configuration. I want to be absolute. I do not want that changing. As soon as I start making edits to that, well, now I might have broken something. It's no longer consistent. So I separate into a parameter file the things that will actually change. So let's have a little look at a ARM file. So this was my kind of demo script for PowerShell and CLI. And you'll actually notice in these, for both of these examples I had, again, this is really for your learning to have a look at, I have examples of actually deploying a template. I always use storage account because it's easy to understand and see. And I have that here as well for ARM. So I can absolutely deploy these ARM templates using CLI, using PowerShell. But I'm going to close that. And now I'm going to jump over to my ARM templates folder. So again, you can clone this repo and you can kind of follow along. So I'm going to look at my storage account JSON file. Now it's made up of a schema definition that's really describing what the valid resources are, what the attributes are, because one of the great things is you'll notice I'm using VS Code. VS Code actually has extensions. If I go and look at my extensions, there's actually an Azure Resource Manager ARM Tools extension. You can go and search for this if you just search for, I think, ARM, and it will find it. You can then install it, and it will help you as you create your various types of resources. And there are huge numbers of extensions for VS Code. I also have ones for Bicep, which I'll talk about. There's ones for Terraform. There's help for PowerShell, all sorts of different things. So definitely recommend you kind of take a look, and that one actually should have uninstalled because that's the old one. But for right now, I'm just going to look at my storage account. So we can see firstly, we have parameters. So those parameters are things we are going to pass in when we call the template. So we can see here in my example, well, I can pass in the storage account type, and I'm limiting it to a list of allowed values, LOS, GRS, ZRS. Now I also pick a default, so I don't actually have to pass this parameter. If I don't, it will just use the default. Then I have a location. Now once again, I'm setting a default. Now my default, I'm just reading, well, where is the resource group? I'll use that. So technically, I don't have to pass anything to this template. I can just run the template and it will install. Then I can have variables. Variables are things that maybe I'm generating. I can have some functions. We can see it's actually a function. I've got the square bracket. So I'm evaluating these commands to generate a value. So what I'm really doing is looking at the resource group name. I'm making it lowercase because storage accounts has to be lowercase. I'm removing any dashes because that's not a valid character, again, in a storage account. And then I'm adding in standard SA to the end of it. So this is just creating a variable called storage account name that I can then use. So we have two sections so far. Parameters, things that I'm passing in. Now I can pass those in either through a parameters.json file. So here I've got just one of them defined. Again, I can override one or both or none. Or I could actually pass it as part of actually calling the template. I can tell it the parameters I want to use. But this, again, if I was actually doing this between environments, I don't want it part of the command line. I would have a parameters file for dev, for user acceptance, for production. And then I have my variables. Now I want to create stuff. So I have a resources section. And in this case, it's all based around that ARM. I'm saying, well, it's from the Microsoft.storage resource provider, and it's a resource of type storage accounts. Then there are various attributes. So I'm going to set the name to use the variable storage account name that I defined above right here. The location, well, the location, I'm going to use the parameter that we have up here. And then I have an API version. I have a SKU. The SKU name is going to be, again, the parameter that gets passed in or as the default value. I'm hard coding the client to storage v2. I have no other properties. And then I can have an output. This thing is going to spit out at the end. Well, my output is going to be storage account name. So that's a template. I mean, it really is kind of that simple. I can think about, well, I have parameters I pass in. I have variables, which are things I'm going to calculate and then use. Then I have resources I want to create, and then I can spit out an output. Another useful output might be something that only gets assigned at creation time. Imagine I had a public IP address. That doesn't exist till I create it. So an output might be, hey, here's your public IP address. So that was a super simple example, but we saw that simple Windows VM from earlier, which had multiple resources, and I can create those depends on relationships that will guide the order in which it actually creates things. So the point is, I want to use these to create. Now, yes, it's not the prettiest thing in the world, but it's actually pretty simple. And let's actually look at a simple Windows VM. So what I'm actually doing up here is this is creating a virtual machine. Now, again, I always have the same parameters. Now, there's a lot more of them because I'm passing in things like, well, a location, a name for the VM, a virtual machine admin name, which I'm kind of hard coding. Then I'm setting a default kind of password that I'm actually passing in from my parameter file, and that's terrible. Now, I'm doing it for this one because I don't care. This is a local thing. I'm never going to create it. Really shouldn't be doing that. You'll notice one of the cool things is these extensions I have is actually going and looking at the parameter file and telling me what the value is. This is not part of this file. That's why it's kind of in this gray. Nor is this. It's reading it from what it knows is the associated parameter file where it has all these values, and it's just actually associating it over for me. So we have all these different things. Now, the way we should have secrets, and I do it later on in here, is I can think about, well, maybe I'm going to join a domain. So one of the things I have, if I can find it, here we go. I have an admin password. Now for this one, you can see it's actually a key vault reference. So in my parameter file, what I'm actually doing is I am referencing a key vault secret. And the actual secret name is sav admin pass. This is how we should have secrets. I never put a secret in a parameter file. I check it in somewhere now, everyone knows it. You say like key vault. Key vault is where I can put my secrets that I really care about, and then I can reference them from within the file. That's the kind of the right way to do that. Now, just if we look at that key vault I have, so if we scroll to Internet Explorer, and if we look up key vault, in fact, there's the vault there, Savile Vault. There's a couple of things you do have to do. In the access policy for my key vault, I have to turn on allow Azure Resource Manager templates for deployment. If I don't do that, an ARM template cannot get to the secret. Now, I still have to have permissions. I still have an access policy. I'm running the template as me. And we can see, well, John has rights to the secrets. This is not an RBAC version. This is just using policy. I have another vault that is at a secret level. But even for that, I still have to turn on allow templates to access the secret. So the secret is now just stored as a secret. And then the template is referencing that secret. So that's the right way to have things that we actually care about. And obviously I've just got sub, you'd have to put in your subscription ID in here. Don't put them in your code. Put them in something else. Then if we carry on, so I have all these parameters, and again, they can be references to other things. Then we have a bunch of variables I'm working out. And again, notice I can reference other things. So I'm actually looking at my virtual networks and finding the VNet ID for my virtual network that already exists. So there's some cool stuff I can actually do in my templates. I don't have to create the virtual network. Here I'm referencing an existing one. And then I go and create the resources. Again, I go and create a storage account. There's going to be my diagnostics. I create a network interface connected to the subnet. It's just a private IP. Then I go and create the virtual machine. The virtual machine relies on the storage account and the network interface. I have an OS profile where I use kind of those admin names. And then I have an extension. My extension here joins the domain. And that's where I go and use a protected, so it won't get put in any kind of log files, what that domain admin password is. There's a lot here. I'm not expecting kind of anyone to process all of that and just start using it. But the point is, ultimately, it's just chunks. It's just resources and their attributes. That's really all this is. And then I deploy it. So I can think about, well, let's see one of these things. So I'm going to go back. I'm not going to deploy this. We'll start with just the storage account. Now, again, in the repo, and I know I keep saying this, remember the whole point of this is all of this is published as my Azure Masterclass. Now, I've not put part 11 up here yet. I need to kind of push this up. I've got to do 10 as well. So there'll be a part 11. Oh no, there's 10. There we go. So 11 will be here, which is going to be all this code once I actually finish recording this. And you'll see everything I'm doing. So you can use all these files yourself. Now for right now, what we're going to do is I created a resource group. And I think I named it something fairly random. People keep stealing the names. I publish up my code, then people create things with that name in it. So it means I can't use it anymore. So I created rgsav 00724 and it's completely empty. So again, we have this storage account. And then if you look in the file, there's a armdemo.ps1 file. So this is actually going to run through and actually create these things. Now I do want to check. So I set the base location. So if you pull this down and you're testing this yourself, make sure it's in the same location. So if I go and look to where my local copy is of this, so I've got my projects, my Git, there's my Azure Masterclass, and I'm kind of doing this part 11, and right now I'm doing my ARM templates. If I copy this, I just want to make sure I'm in the right place. So I'll put in this value, because I switched between different machines, and it was the same, so that was a bit like, okay. So I'm going to run that just to define my base kind of location. And then the first thing I'm going to do is I can actually deploy that template. Now I'll move to the folder, so I'm going to do cd part 11 down the bottom /ARM templates. And I can see all these various templates. So I'm in that folder. So I'm going to use the new AZ resource group deployment. Again, I've already installed the AZ module. You have to do that first. I'm going to tell it the template file. And I'm passing it a parameters file as well. And I'm going to run it. Now, I'm doing what if. So one of the really cool things here is it does support what if. So if I just run this command, it's complaining straight away that resource group could not be found. So what I suspect is happening, if I do get AZ context, I'm looking at my prod, which is the wrong one. So I'm going to do select AZ context. I'll pretend this was deliberate. Saviltech dev. So I have 3 different contexts, my prod, my dev, and my lab. Now, in that other source code, I actually show you how you can set up these friendly names to make it easy to switch between them. So again, in this file, when I go through so many folders, this demo script.ps1, I actually talk about how you can get a list of all the contexts, dump them to a variable, and then you can look at them quick and then rename it to whichever name makes the most sense for you. And then I can jump around. Anyway, now let's try and deploy it. Now I'm in the right subscription. So what it's doing now is it's actually looking, what is the current reality? What is the desired state? So it's saying, hey, you've got this and this. I'm going to look at, you specified a resource group. So I specified a certain resource group. By default, it's doing something called incremental. What that means is in that JSON file, we'll just say, hey, I said I want storage account 1. So right now it's looking, does storage account 1 exist? If it does it match the various attributes I have? If it doesn't, it's going to make it so it will go and create storage account 1. Now, if there was other stuff in here already, let's say there was a SQL database or a VM, it will leave them alone. Incremental only says, hey, the stuff I define, make sure the stuff I define is exactly meeting that spec in the target. If there's other stuff in there, I don't care. I don't see it, la 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 la. I don't want to know. Okay, so let's see what our VS Code is doing. So what if is telling us, hey, if you run this, then it's going to create 1 resource. That sounds good to me. So I'm just going to now execute without the little dash at the end and the what if to actually go ahead and create it. Now there's always a lag between the portal and the actual resources that exist. So right now you can see this resource group is empty. That's kind of the key point. Once this finishes, it will have created the storage account based on this configuration. So it's the name of the resource group with stdsa at the end of it, standard SA. Now the default value was standard LRS. My parameters file was also standard LRS. So it should have created a locally redundant storage account. If we go and look, and again, it's going to be a delay, so it's not there yet. Normally within 30 seconds, it should show up, but there's always a little bit of delay between them. I could go and look in PowerShell or CLI, I'd see it. But if we keep hitting refresh, okay, now it's there. So if I actually go and look at this thing, I can see, hey, look, it's locally redundant. Great. Now let's test our theory. Maybe I want it to be GRS instead. I made a mistake. It should be GRS. Okay. So now we're going to go back to the code. And this time, what we'll do is we can do one of two things. We could change the parameter file, or I can just override it by specifying the storage account type. So I'm actually overriding the parameter. So I'm going to do that. So currently it's LRS. Now I'm not going to change the file. I'm not saying, well, now you have to do a modify. I'm saying my desired end state is now it should be GRS. Now once again, remember, I could actually run a what if. So before I do anything, tell me what you would do. And if I run that, it's once again, it's going to go and look at, well, what's there right now? And what do I need to do to make that the reality of your world, my great master John? And what it's going to basically work out is, well, the storage account type has changed. And you see that. It's telling me, hey, look, okay, I'm going to have to change the SKU name from LRS to GRS. Okay, I'll take the what if out and go and do it. So now we'll run these commands. F8, go run. So now it's actually going to go and say, okay, I'm looking at reality again. Currently I'm LRS. I've been told the desired state is now GRS. It's its job to go and work it out. Now again, this applies to any type of resource. Now there are some things maybe you can't just change. It depends on the resource. But if it's possible to modify the attribute and the type, it's going to do that. I can have things like other containers created. I can do all of those things for my declarative configuration. I can even do things like assign roles, I can assign policies, the things I might use blueprints for, I can actually do with ARM templates. I can have all of that stuff defined. So if we go and look, so it's finished. And again, it would have told me in here, kind of the values. So it's now got this standard GRS is actually listed in there. But in the portal, if I just hit refresh, hopefully, now it says GRS. You can actually see that GRS. So it did it. I just changed what my desired state was, and it kind of did it for me. Now, in the repository here, I've got just other examples of things. So if you actually walk through, I've got things like I create a virtual network, then I create a version with multiple subnets. And actually, I guess I'll run this one just for a bit of fun. So what I've got here is a template file that deploys one subnet. So if I actually looked at this, it's just a single subnet. So it's defining a virtual network. And then under the virtual network, it defines a subnet. Nothing fancy. Now remember, this template, only defines the virtual network, not the storage account. But if we run this, I don't need a parameter file, it's just going to run defaults. Doesn't really matter. So now what it's doing, if we actually jump back to the portal for a second, and if we go back to the resource group, so the storage account exists, but right now I'm defining another resource in a different template, remember. So now let's say it's a completely different template. And this is now network with that resource. And I'm deploying it to the same resource group. In fact, I'm going to change the colors just so we can kind of see the difference between which is which. So now I'm also going to have net1 show up. Now it doesn't affect the storage account because this is an incremental deployment. It's only looking at what's defined in this template. Make sure what's defined in here matches in that target resource group. Now I should say you can actually deploy templates to subscriptions and management groups as well. It's more common that we deploy to a resource group, but it's absolutely possible in incremental to actually target subscriptions and management groups as well. Then you can actually go and create resource groups, go and create subscriptions if I target a management group. So now it's going off, and now it's finished. So that finished. So now if we go back to our portal, what's happened to this resource group? Their storage account. It's still there. It didn't mess with it. And if we look at our virtual network, well, what we're going to see is it has one subnet because that's what we defined in the template. Now what I'm going to do is I have another file, same name, but this one has two subnets defined. But it's the same virtual network object, but it defines a second subnet. So my desired state, even though it's a different file, doesn't matter. It's the same resource name. It's going to update the same resource. But now my desired state is where it has two subnets. But there's also a complete mode. And I'm going to run this in complete. Now, complete is dangerous. What complete is going to say is, hey, look, I want the resource group to look exactly. So ordinarily, we're deploying incremental. Just make sure the resource I have in the template matches the resource in that resource group. If I say complete, it says make the resource group exactly match the template. So if there are resources in here that are not in that template, it's going to delete them. So it's a dangerous operation to actually do. And I believe it's actually going to warn me. So if we actually go and look at this, so if I run this, and this time remember, I've got this mode complete added to the end. So if we run this, it's saying, are you sure you want to run a complete deployment? It's basically saying, hey, look, you really can cause a lot of damage with this thing. It's down the bottom. So I'm going to say yes. So yes, go ahead, go. So what my expectation is now, because I'm doing that complete mode, and again, you want to be super careful with this, I'm actually going to expect this to delete. Now, I could have done the what if, actually would have been cool to show that quick. But it would have shown, hey, I'm going to kill this thing off. I'm going to delete this. So once this completes, we should see two things happening. I should now see a second subnet on the virtual network because my desired end state for that VNet is now two subnets. And I should see the storage account gone. It's just going to kill that thing off. So that's running through. And again, there's always a lag again. It would hit refresh. So it's still there right now. It's still running, it's going through. But that's what's going to happen. So when I do that complete mode, this is going to kill off. Now, obviously, I could reapply this in incremental again, and it will recreate it. But with that complete turned on, it's actually going to go and wipe that out to make it exactly match what I have in that script. So it's still running, taking its time. Again, because I'm modifying the VNet and I'm destroying something, it's just taking a little bit longer. Okay, so I'll come back to that in a sec. So the whole point is, yes, we have that great ARM extension for VS Code. Use it. And again, I can offer these. And what the ARM extension is actually going to do is, as I'm typing things, it will help me. I guess I could show that. So while this is running, oh, it's actually finished. So we jump over. So it did finish. It will tell me, can scroll up. So okay, so that's succeeded. I now have a virtual network. If I look at my VNet, my subnets, I have two now. It's made that my reality. If I refresh my resource group, my storage account's gone. It killed it. So that's the challenge with complete. You really do want to be careful with that. And I'm actually going to delete that VNet as well. Now, obviously, I could delete the VNet by redeploying the storage account in complete mode, but I'm just going to go and kill that off anyway. But with VS Code, if I was to look at my JSON file, let's, for example, I'm going to take out, let's look at something. Let's take out kind just to show something. Because it knows what I should have. So I'm going to take that out. So now as I start typing, it's showing me, well, look, these are the valid kinds. Storage v2, storage, file storage, etc. If I take out the quote completely, it shows me, if I just type K, hey, look, there's kind is available, and it's required. And then I could say, okay, then it shows me what I can do. So it helps me actually create it and populate all those various things for me. There's also, again, I can export it from the portal, and Visual Studio has a full kind of creation, but honestly, 99% of the time, you're just going to go and use one of the GitHub templates and start with that. It's really just kind of the better option. Okay. So we have the whole incremental versus complete, and I can do other things. I can link, I can nest. Imagine I had certain components I create a lot. Rather than cutting and pasting it into the same file over and over again, I could store it and link to it from other templates. And in the repo, I have examples of both nesting and linking. Again, I'm not going to go into the detail. It's starting to get a bit too involved. You can only digest so much stuff. But if you actually, I'm not going to save that. But nope, don't save. But I actually have examples down here of, if we look, for example, there's a storage account linked. And what I can do here is I can deploy a resource deployment. That's the type of resource I'm deploying. And I can just link to a template. So this, for example, would be, for example, a shared access signature to a file in blob. Or I can actually nest it. So here, once again, I'm creating a type resource deployment, but here I am cutting and pasting it. But then I'm actually doing the resource as part of that actual resource there. So different ways I can reuse pieces of code. Again, that's more advanced, But I've got the code in here if you wanted to kind of look, just in case you're curious. And just one last thing to kind of show that JSON. So one of the things with an ARM template, I have a key vault test. Now I don't actually have to create a resource. I have a parameter here that's just a password, and then what I'm going to output is the parameter, both as a secure string and a regular string. And then my parameter is the lookup to the vault. So if I jump over for a second, if I go back to my vault, and if I go and look at the properties of my vault, I can actually get its resource ID. And what we can do is I can paste it into the ID of my vault here. There we go. And save it. So now if I just run the template to actually look at a secret, just to kind of demonstrate this thing, because that vault had that ARM option turned on, so it's allowed to interact with ARM templates, you can actually see, hey look, it went and got the secret. Password. Super secure, awesome, but it's absolutely there. I can do that. So this is how I'm going to put secrets. Do not put secrets actually in your code itself. Make sure you go ahead and have them in a vault and then reference it from the vault. Okay. Those ARM templates are not the friendliest things in the world. Currently in early preview, it's on a version 0.2. There's something called Bicep. Now, ARM can be intimidating. So what Bicep is an alternate language. If you've used Terraform, it looks a lot more like Terraform than ARM templates. Now, it compiles to JSON. It's just a different language I can use to create kind of the files, the declarative files, but it then compiles to JSON. And it's the JSON I would then actually deploy. But it's far easier to create and understand. Now, at the time of recording, it's in 0.2. It doesn't match ARM functionality completely yet. There's no concept of kind of loops, for example, and conditions. They just added module concepts in 0.2. Once it hits 0.3, I'm going to do a deep dive video. So if 0.3 is out, I'll have a link to it in the GitHub repo for other videos, and I'll go into detail on it. For right now, just to give you an idea though, is if we jump over, if I actually, again, I've got the file in my repo, so we can kind of see this. So I'll close this down. I actually don't even remember what I changed, but we'll say no. I have a Bicep folder. And you can see I have a Bicep file. And I'm going to delete this storage account JSON file. I don't want that. And we can see, well, I have parameters. I have a location parameter. And I have a name parameter. Then I have variables. And then I'm creating a resource of type Microsoft.storage storage accounts with a particular API version. Then I have the attributes. Well, name is using the name from the parameters. And notice I've got the Bicep extension installed, so it knows, well, hey, this name here is the parameter up here. The location is that parameter there. The kind, storage, is of name storage SKU, which is up here. And then output the storage ID. That's it. That's a Bicep file. And once again, because I have kind of that Bicep extension installed, we'll pick on kind again, I can just start typing and it knows, hey, you need kind. And then here are the options you can do. So it gives me those capabilities. Now remember, this is just an authoring language that's far more friendly to use than ARM, but it compiles down to ARM. So what I would then do, now there's a whole thing to install it. Go to the documentation. I haven't installed Bicep, which is what I did. But this really comes from the Microsoft docs. So I wouldn't particularly follow this. I would follow the Microsoft docs, but basically it installs the Bicep compilation, the language itself. it puts it in the environment path, and then I fetch the latest VS Code extension and install it. That's all the install does. To actually use it, I just do a build. Again, I don't apply Bicep. I compile a JSON file. So right now there is no JSON file. And let me actually quickly move out of ARM templates and move into my Bicep folder. Let's clear away. And if I look right now, there's no JSON file. So I'm going to do a build. And now there is a JSON file. Oh, wrong tab. Now there is a JSON file. And remember what we had in the Bicep? 2 parameters, a variable, a resource, and an output. The JSON file it's created has 2 parameters, a variable, storage account, and then an output. And look at all of the JSON that came. So here's the Bicep file, here's the JSON file. So you can see why Bicep is more attractive in terms of kind of authoring experience. It's just much nicer to use. Again, it's version 0.2 at time of recording. Once it hits 0.3, it should be ARM matching. All of the features of ARM should be in Bicep. Also, what they're working on is things like, well, I can decompile JSON to a Bicep file. But remember, Bicep, there's no state file. It's not like Terraform. Terraform has to have a state file because it works against all these different resource providers, so it has to kind of map its state somewhere else. It can actually be problematic. It doesn't need it. It's just Azure. So there's no state file still. It's just a nicer language that fundamentally, if we go back to our other picture here, you could now almost think about what we're now having is, well, now I can have a nice Bicep file to define my resources, which I then compile or transpile, depends on what word you use, the right things, it's not really compiling to exe, to a JSON. It's the JSON I can do what if and deploys with. So that's kind of that relationship. So this is just a much nicer kind of authoring experience. It's far more intuitive than doing that kind of clunky JSON file. So that's the infrastructure as code part. That's me thinking about I'm designing and deploying my resources with declarative technologies. Now, once I've done that, now I've got these declarative files. And I remember when I started off, I would write configurations, I would change it. So then I would create kind of a underscore v1, underscore v2. I'd rename the old one. And so you end up with all these different files for my different versions of the thing. And you change something, you're trying to work out, well, what's different? It's like, oh no, I've lost a bit of code, and you'd be kicking yourself. So the whole point of a version control system, and Git is an example of one of these, and it's kind of the popular one. I can now have different versions of my project stored. I can have snapshots at point-in-time views of where exactly I am, and I can make changes of V1, V2, V3. I can see exactly the various history of what I've done to those files. And so Git is that version we're going to focus on. Again, there are others, but again, Git is kind of the standard. Git is integrated by default with things like VS Code. GitHub, Azure DevOps are all Git compatible. So if I think about Git is a methodology for the storing and tracking by these kind of commit hashes that get generated. I can store those in remote repositories as well, but that's later on. We don't have to worry about anything remote. We can just use this locally. But I can have concepts like branches. And we'll go through this, but the idea is I basically have these snapshots, which are point-in-time views of all of the code that makes up my project. Well, I might have different people working on this at the same time, but they're doing different aspects. So I can branch out the code so they can have their own views and then merge them back together once maybe that piece of work is complete. So they can work in isolation so they're not tripping over each other, And then once they're complete, we can merge them back in, get the benefit of everyone's work. Now this is used by, as I said, most of the online repositories, but we can start locally. And one of the key things with Git is, even if I have a remote repository, I always have a full local version. So I could be on a plane, I could be completely offline. I still have the full history. It creates a full local copy of this on my machine. Now to get started, you have to download Git. So I can go to git-scm.com. And as we can kind of see here, what we have is this is the version control. It's completely free. And I can go and download for Windows, but it's available completely cross-platform. There's all different versions of this available, but I would go and download this, add it to my path. So now I can just run Git commands. And one of the things I would say is, from a documentation perspective, this book, this Pro Git, is phenomenal. It's completely free. You can actually download it as a PDF file. So some of the things I'm going to be talking about is really all based off this book. This book has, if you're trying to understand anything I talk about, this is far better and has great examples. It has, well, many of the things like pictures to show through exactly how this works. Branches in a nutshell, I think, is one. So it shows you how those branches can work of things, how I can have them actually coming back together. This is what you should go and look at. So I'm going to cover some of this fairly quickly. No way I can do this justice, but you can look at this online. You can download it as a PDF file or something else. It's absolutely phenomenal. But the first thing you have to do is go and download Git. Now, once you've downloaded it, you then would kind of go and integrate it with your actual environment. So I've downloaded Git. I've installed it on my machine. I have all of this kind of running already. Don't need any Git templates there. So then in my environment, I can actually use it. So if I think about, okay, just go back here. So that's kind of the download for it. So I've got the book, I've installed it. What do we do now? So the first thing I would have, now I'm really just going to jump over to demos of this. So the first thing we'll actually do is, for the demo, I'm actually going to create a new area, because to really show this and without getting it all confusing, obviously I'm running off of a kind of repo already. This whole project is a Git repository, and you can actually see I've got things like the source control. There's all history in here. This would kind of get messy if I was going to try and use this. So I'm actually going to kind of take this out the way. And instead what we're going to work on is we'll just create a new one. So if I think about, for a second, if we open up Explorer, what I'm going to do is create a brand new folder. And we're going to use that. So on my PC, I have a Scratch folder, and I've created a folder called Storage Repo. And all I've done is copied in the storage account JSON file. Now, what I actually want to do is, rather than it being in that folder, I'm going to create a folder called ARM templates, and we'll put the storage account in there. So I just have this. So what I'm going to do is now is open code in that folder. So this is what we're actually going to work on. So if I bring this over here, this should look familiar. It's the same file. Now, right now, we're not using Git. This is just my local machine. If I look ls, I've just got kind of ARM templates. There's nothing else available. So what I want to actually do is start using the actual Git to start change managing this. Now, the first thing I need to do, if I want to integrate, for example, VS Code, VS Code has source control built in. Now, right now it's saying this is not a Git repository. It's offering me the option to do the init for me. To enable it to do those things, to understand Git, if I go to the command palette and open the settings JSON, I have to do a few things. The biggest one is I have to tell it where Git is. So I've downloaded Git. Go and find it. You have to do double slashes. Tell it where Git is. I've got things like auto fetch turned on, confirm sync is off, enable smart commits turned on, ignore missing. Some of these, obviously, I've changed to PowerShell 7 instead of the Windows PowerShell. So in your VS Code, you can go and do a bunch of different things. I'm using the PowerShell ISE color scheme because I'm old. But you have to go and kind of light it up so it understands actually what it can do as part of the all-up capability set. So right now, if I just go and look, if we go down, I can do get, and I'm going to do F2. So I've got this PS readline extension turned on. If I do F2, it makes it inline. But I can do get -- version. Because it's kind of Linux based, you'll see double dashes. So this is the get version 2.29.2 Windows. I'm all good. The first thing I have to do is set up some git config. And there's kind of a global username and a global email. Now I've already done that. So if I do get config -- global, I can do local to do it at a particular project. But you notice I've set up my username and my user email. Now, everything I'm going to do, I've got in the repo. So if I quickly drag this back over just so you don't start panicking. Everything I'm going to run through, if you go to the script under git demo, I have every command I'm going to run as part of this. So I wrote it, I practiced it all, because I'm not that good. This is everything we're going to do today. So you can follow along and do this yourself, but I just wanted to show this in action so we can kind of track it. So what we're going to do is actually the first thing is I have to create this as a repo. So right now I can just do get over here, git init. Now this is the same thing that I could click this initialize repository, hit enter, and it's done. And notice straight away VS Code has noticed, it's like, oh, you're a repo now. But you've got some changes that are not quite ready yet. You've not committed this stuff yet. We're not going to worry about that for right now. But I now have a repository. If I go back and do an ls, I can't see anything right now because it's hidden. But if I actually go into here, we can see there's a .git folder that's completely hidden. That's where it's storing everything. There's a whole structure and there's documentation that goes through exactly what that is. But I now have kind of that repo. Let's close my settings file. So now we can actually think about doing things. So I have this file. Now when I think about what Git is going to do, it's essentially now 3 places. I can think there's my local file system. So my local file system is kind of the working area. Basically, I check out a certain branch of the repo. So by default, it's master. Now, obviously, the world we're living in today, that's not a good term. So there's actually things right now to change that to main, or you can actually name it anything you want. But I'm keeping master for now, just for consistency. If you're seeing other things, that term is going away. It will become main or something you pick. So that's my local file system. So this is kind of my folder, my local machine that I'm creating, deleting, editing stuff in. That's my folder I see. Then I can think about, there's kind of a staging area. So the staging area is where I put things that I'm going to want to put and commit to my actual repo. So then we obviously have as well the actual repository. Now you can kind of think about it as this is the actual, my long-standing repo, this is my history. Because when I do commits, a commit is nothing more than a snapshot. A commit is a point-in-time snapshot of everything in my project. That's what a commit is. So I'm going to work on files in my working area. And so we can really think about it as really, for me, I just have my JSON file. And it's the blue version. So right now I've created a repo. So I have a staging area. There's nothing in staging. There's nothing in the repo. All I have is in my working area, and I can have lots of files. Until I stage it, really Git doesn't know anything about it. So the first thing we kind of want to do is if I jump over to my code, so here we're looking at it. And I really don't even have to have this storage account open. I'm really not doing anything with this right now. So I'm going to make the bottom window a bit bigger so I can kind of see that history a bit more. So if I'm actually in this bottom window, there's commands I can run. So firstly, if I go into my ARM templates folder, I can do a get status. Get status shows there are untracked files. So it's like, hey, look, you got stuff that you've not committed. So the first thing I can do, now I can do a get add and the actual name, storageaccount.json. If I now do a get status, now it's saying, hey, look, you've got changes to be committed. So what I've essentially done right now is with the get add, what get add has done, so that's doing an add, that's now staged it. So that's now in staging, but it's not part of a commit, it's not part of a particular snapshot, because I could continue staging other files. So staging is what I want the next commit to have in it. That's kind of the goal of it. Okay, so I've done the stage. So now, what we'll actually go and do is, well, now I actually want to do the commit. So what I'm going to say is in here, well, okay, git commit, and I give it a comment. If I don't do this, it will prompt me and ask me, git m add the storage, can't type, account.json file. And we can see a few different things. Now, it's created a kind of a hash for this commit, and it shows us the first 7 characters. And I can see, hey, a file changed, there were 48 insertions. It's showing me what the hash is. So now if I do get status, there's nothing to commit, and the working tree is clean. If I do a get log, well, I can see, hey, yeah, look, there's the full commit. I can see the head. So the head is the pointer to the branch I'm currently working on in my working area, is pointing to master, and master is at that particular commit. I can see who did the changes, when, yes, it's Sunday morning as when I create all of these. So what did we just do? So if we go back to our picture, what's now happened is we can kind of think about, we took the staging as it is right now, and we essentially created kind of this hash 1 as a bubble, essentially. And what's happening, so all of this, kind of the current state, this was a commit. So created that hash value with the contents as it is. Now, behind the scenes, Git actually stores the entire contents. It doesn't do deltas, it's storing all of it. But it then packs it down. If there's files that have not changed, it points to the original hash of that file. It does efficient things behind the scenes. And essentially what's happening is, this is my main branch, and the pointer, my head pointer, is pointing here. So this is what I'm actually working on. So that's my main branch, and that's where I'm working. So we kind of took all of this down to create that particular hash version. So that's the layers, what we do. So we work on stuff. When we're kind of ready, want to commit it, we stage all the changes. There might be other files I'm not ready to put in the commit, so I leave those there. Stage it, and then I commit it through. Okay, so let's kind of carry on with this. So that's good. We've got that information. Now, one of the things I can actually do is get a lot more kind of information about the various things. Because I've got kind of this get log and I can see it. but I can actually do a git log. Oh, not typing. There we go. Git log. And I can do this thing called do a one line. And actually it's showing me that I typed it before. It's on one line, decorate graph all. And that shows me, hey, there's kind of the commit hash, and there's that my head is pointing at the master. So I'm kind of up to date. And rather than keep typing this over and over and over again, one of the things you can absolutely do, now I'm in PowerShell, so I'm going to create a function. If you were using Bash or something else, you could just do an alias. So I'm creating something called getGraph that maps to that command. So I can now just do getGraph and see that whenever I want. So it's rather than me typing all that stuff out every single time, I can be kind of lazy. So what we're going to do now, let's change something. So I'm working on my project and I've decided, well, hey, I'm going to change the default to GRS and save it. So now my working, you can see, so Git is noticing, hey, look, you've got some changes here. Do you want to stage them? But I'm going to stick to using get, but realize I could do all of this from VS Code. I don't have to use get directly. This can stage it by clicking the add, then I can type a comment in and actually do a commit. So this can do all of this for me. So what I've now got to is, well, I've changed the file. So now you could imagine, well, now I'm kind of in my working area, I have a slightly different version of that file. So the staging still has the old one, but it can see there's a difference between it. It knows I'm not up to date anymore. So what I need to do is add it again. So now it would have this version. And then I want to commit this. So I would now do a commit. And it will generate a new hash with that file. And now my main will move up. This is my main branch. And my head would kind of move with it. So that's what we're going to kind of go through. So now we can actually see this. So we actually run our get graph again. So we saved the file. Let's just clear this so it's easier to see. If I run get graph, well, it doesn't know anything yet because it's just in my working folder. So the first thing we need to do is, well, get status. It sees there's a file that I need to stage. If I do git diff, it's showing me, hey, you've changed LRS to GRS. And once again, in VS Code, because I'm in VS Code and it's awesome, I can actually double click storage account in what it's showing me and it shows me the same thing. It's saying, hey, look, these things are different in my working tree. So the difference between my account and what's in my working tree is this. Okay, so what we're going to do is we want to add it. Now I could manually add the file. Remember, add moves it to staging. Or rather than adding each individual file, I can just do git add dot. Everything that's different, go ahead and stage it. So now you'll notice in VS Code, it's moved it up to stage changes. If I do my get graph, well, it still doesn't know anything. But now, if I do my get status, now it knows there's staged changes to go through. And now if I run a get diff staged, it knows, well, the difference between what's staged and what's actually at my head in my main branch is that change. So now I can commit it. Well, let's commit it. And I'll just say changed rep. So I'm lazy and can't bother to type that much. Now if I do my get graph, my state should show there's clean. And my get graph will show, hey, I've moved up. So my head, my master, has moved forwards like I showed in the picture. We still have the original hash of that first commit, but we've now actually moved forwards to the new hash we just generated when we did the commit. So 217C, 217C. So that's how we're working on this. We're tracking our changes. We can see exactly what's going on. I could absolutely, let's clear this again. If I do a get log, we can see, yep, so I can see the history. I could see the detailed changes. If I do a get log -p, I can scroll through and it said, well, the last commit, hey, yeah, you changed the default value. Then it will actually show me all of the changes from the first file, which was creating it. So there's a lot of stuff there. And then Q gets me out of it. So now I've actually gone through, and that's awesome. I've got this ability now to track and work on things, and I could go and see the history. It's all being kept. So I can always go back. I can kind of move between. I could check out. So I could check out different versions potentially. I've got that kind of full history. Now, what if I have files that I don't want to be stored? Like I might have secrets sometimes. So one of the things I can actually do is, let's say I'm in my folder and I'm going to create another file called secrets. And never tell. Doesn't matter. Now, I don't have to add it. Absolutely. I never have to add this file. But the problem is it's going to constantly be nagging me. It's going to constantly say, hey, look, you've got this file. If I do a get add, it would add it to it. So if I have files that I don't want in a certain folder, I can just create a file called .getignore. And in that file, put the names of the files you don't want and save it. As soon as I hit save, notice secrets has now gone grey and disappeared. That's what that does. It's now not tracking it. Now, get status will now say that the gitignore file needs to be there, which I want. That I'm quite happy. Now I can just do get add, and I can just say get commit .gitignore file added, and now my get status should show I'm clean. My get graph shows now I've moved up again. Because what I've essentially done now is, well, I added a file, remember? Now we'll say this color. I added .gitignore. I did an add. Remember that file was already there. So now I've got my .gitignore file. Now I've done a commit. So everything staged is now gone into #3. Which has now got my JSON and my .gitignore file. And once again, my main has moved forwards, and the pointer to what I'm using went with it. So that's kind of the point. But I've got that full history that we can see with what we're doing. So that's Git. I mean, that's really what it's all about. Now, what if you do have multiple people? So we have this very nice, easy picture. So we'll scroll up for a sec. Where I'm having my different versions going up, just my main. And I'm saying main, not master. Now, what if I want to work on something and commit it? I want to save it, but it's going to be in progress. I don't want to mess with kind of what my main, that the master is actually doing. So I can create branches. So let's say main is currently here. I can actually create a branch. So maybe we're going to do some ZRS. We're going to do ZRS replication. So I can add a new branch, which initially will point to the same as main, the same hash, whatever it is. But now my head is pointing here. So I can now go off and, hey, I'll create a change and I'll commit it, #4. And ZRS will move forwards. My head will move forwards because I'm committing now to a different branch. Now, technically, someone else, well, they could create their own branch. Maybe they're creating something like, I don't know, SA storage account kind. And they're making changes so they get kind of a #5 version because their head is over here. They're working on this version. So we can absolutely do all of those things, and then eventually we'll merge them back and we'll get back to main. Now these where we start to get, there's like three-way merges we can do here. I'm not going to cover that. It's not even more advanced, it just has a recursive check. It will work out, hey, can I merge these things in if there's collisions? So maybe we change the same property. It will open up a file showing me the two changes, and I get to pick which ones we keep. So it's not even like it's more complicated. It's just a bit beyond what I'm going to try and cover in this amount of time. But I can go and work on this, and what I can do is when I'm happy and with this commit and I want to bring this back into main, I can actually merge my branch into main, which will now make main come up to here as well. And because ZRS was a direct kind of child off of main, I can do a fast forward. I can just say, well, main now points to this. Again, if I was trying to bring all of these together, I can't just fast forward. Then we have to do this traversal, this three-way merge. But here I can just bring it in. And then once I did that fast forward, I can actually change my head to now point to main because it's the same thing. And then I could just delete the ZRS branch to keep it clean because it's not needed anymore. I've done my testing. I can now carry on, and I'm essentially just using this. So that's one way I can use branches. I'm working on some code. I want to do things around that. I commit it. Once I'm happy, I'll merge it into main and then carry on. So let's actually kind of see this in action. And again, all of this is in kind of that sample code that we have in the main repo. So we're back over here. Let's clear this out. Let's get rid of this git ignore file. Just got our storage account. So what I'm going to do is right now, I'm going to create a new branch. I'm going to do get branch ZRS work. So I'm going to create a new branch called ZRS work. If I do my get graph, I can see, well, they're pointing to the same thing, but now I can see, well, I do have a new branch, ZRS work. They're pointing to the same thing. But right now, I'm still pointing to master. So what I'm going to do is I'm going to say, well, actually, I want to use ZRS work. So I'm going to check out ZRS work. Now, if I do a get graph, my head pointer now points to ZRS work instead. So I can see here, I'm pointing to ZRS work, right there, instead of master. Well, now I can change things. So right now I'm going to change my default value here to ZRS instead. Save it. My get status will show me, hey, there's modified files that you've not done. So I can add it, get add dot. I can do a get commit, updated to ZRS. And if I do my get graph now, I can see I've moved forwards exactly as I drew in the picture. My head is now pointing to ZRS work, which is a hash beyond master. Now, once I was happy with that, if I'm good, I've done all my changes, maybe there's other commits and I want to put it back into master, well, I can check out master. So now my head is going to point back to master. So get graph, I can see, hey, I'm now behind essentially ZRS work. I'm pointing at master. And now I could do a diff, I could do a git diff, master to ZRS work. And it shows me the differences between them. And now what I'm going to do is I'm going to get merge ZRS work. So I'm going to merge in from that branch into where I'm currently pointing, which is master. And what it's going to do is a fast forward. Now it's showing me that. If I look, notice it's saying fast forward. Because it was a direct child, it could just move it forward. And now my get graph shows head and master are pointing at the same thing. Now, because of that, ZRS work is kind of finished. I'm not working on it anymore. I can actually have a look, or show me all the branches that are merged. And it shows me master and ZRS work are pointing at the same thing. So now I finished that bit of project. I want to keep it clean. I will just go ahead and delete ZRS work. And now my get graph is tidied up again. So that's me really kind of going through various different kind of actions, keeping those changes. And again, it's all local. I've done nothing beyond that. Now, I could absolutely do nothing else. I could stop there. I could just use it locally. I don't want to make sure it's protected, but I can absolutely just have that. I could maybe store it on OneDrive, which is where mine is, so it's replicated. But then we think about repositories that are kind of online. And what we can now have when I start doing these types of things is, that's good if I'm collaborating with others. Maybe I want other people contributing to my code. Maybe I just want to share it. Like my main repo for this masterclass, I could have just kept locally for my own code, but then you couldn't get to it. So I can put it on a public repository. Now I can also have private repositories. I could have had this on premises. I can host Git servers. There's many different ways to do this. But the option I now have is to tie into a repository. So GitHub, Azure DevOps, and many more things like Bitbuckets, others provide Git compatible servers. So the whole point is Git is that kind of mechanism and tool set to maintain the histories. And then these services are Git compatible, so they can store those repositories kind of online. They can be private or public. I'm going to focus on GitHub. Now you might think that's kind of weird because Azure has Azure DevOps. Well, Microsoft bought GitHub. Excuse me. Well, GitHub's the future. From a repository perspective, it's better than Azure DevOps. From a continuous integration perspective, when I think about continuous integration, continuous deployment, delivery, DevOps has some kind of gating concepts that's better than GitHub Actions today, but it's going to catch up. I'm just going to focus on GitHub. Now, I have other videos linked in the repository for this course, the README, where I go into using Azure DevOps. I also got a more detailed video on using GitHub. I've got more detailed videos on using Terraform. So go and look at those. I'm going to focus on GitHub. So I'm going to create a GitHub account. It's free. Go to github.com and create an account. Then I'm going to create a repo. Now, all of mine is local at this point. If I know I want to make it public, I would go and create the public repo first, or private repo. Create the repo first, and then I would clone it, create a clone to my local machine and work on that. It automatically now maps that remote repo. Normally it's called origin, but I can name it anything I want. That remote origin is the corresponding to my local. It makes some things easier, but I don't have to. We've already created our local one, so I'm going to kind of extend that out. So what we're going to start with is in GitHub. So I jump over to the portal and kind of go home, and I'll go to GitHub. So in GitHub, I already have an account. Now I'm looking at my Azure Masterclass right now, but I'll go up a level, and what we'll do is we'll create a new one. So I'll go to my repositories. So repositories is kind of up here. I'm just going to say new. Now it really doesn't matter what I do with this. I'm just going to call it storage template. I'm going to make it private. I can put in a description. I could say initialize it with a README file, add a .gitignore. I'm just going to make it empty because I've already got that repo locally. And what I'm going to do is I'm going to push it up to be remote. So I'm going to say, hey, create repository. And then it's going to tell me things to do. Hey, look, we'll go and create a README file is the first thing you should do. Then if it was starting new, I would init. Well, I don't want to do that. But then I would add the README file. I'd commit the README file. Now, this is where I could use a name other than master. So it's saying, hey, I can actually create a branch, main, and make it the main one. And then I'm going to add this repo I just created as the remote origin. So it's telling me everything I need to do to actually kind of make this the reality. There's other ways I can go and populate this, but right now it's empty. There's nothing in it. So we need to kind of go through and make this our world. So remember, I've still got my storage account. I'm kind of sitting in here on my file. Let's clear this. So we kind of can go through all those commands it kind of just gave us. Now I'm in ARM templates. I want to go up a level first of all. So we'll go cd ... And the first thing it was kind of, well, echo in storage template readme. Okay. Then it was git add readme. Then I'm going to go and do a commit. So I can say, well, git commit. And I'm just adding the readme file. Now I want to add that remote. So what I have to do is that command it kind of gave me, I'm adding a remote origin. So if I just paste that in, I've now added a remote origin for my environment. And now if I do actually do a git remote -v, I can see I've got that remote origin, both a fetch, i.e. getting stuff from it, finding out the metadata, and the push. So at this point, what I've kind of now done, if we think about going almost back to this file here, this, well now there's a cloud version. I've now created another repo up here, my remote, and again, I can call it anything I want, but I've called it origin. And right now it's empty. It doesn't know anything. But what I've now added to my environment is a remote called origin. So I now know about this remote origin thing, but there's nothing there yet. I need to take this and I want to push my main branch to origin. So I want to push to remote origin, my main. So that's what we're going to do. Then then it would have all of this, and it's going to take the whole history. Then all of this good stuff I've got right here. Probably not going to copy and paste this properly. So I'll copy that. And then, if I'm lucky, wrong one. Paste. Oh, there it is. Don't know why I pasted it over there, but I'll have this now as part of my remote as well. And I can do various, it didn't copy and paste it all very well, but you get the idea. I'm going to basically push it over to that remote origin. So I can think about, well, yeah, I can push, and then I can do things like fetch, which just gets the metadata, and then I can do a merge, or I can do it all in one go and just do a pull. So I have these kind of choices in how I'm going to interact with that. Okay, so let's go back over here and do this. So right now, if we look, if I do my get graph, it doesn't really know anything. I'm up to date, I'm fine, there's no problems with anything else. So I've added my remote origin. Now I want to push to it. So I'm going to do a get push to origin to a branch called master on that remote. Now, before I run that command, if we quickly look at GitHub again, and we kind of refresh that thing, it's empty still, there's nothing there. So we'll go back, we'll run that command. Now, at this point, you would have to actually authenticate. To pull it down to clone, anyone can do that. If I've made it public, now this was private, so it wouldn't have worked. We have to authenticate anyway because it's private. But to push, I would have to get an actual token to be allowed to do this. So at this point right now, I have to have permission to do that push. But again, if it was public, anyone could go and clone it. So we go back. So that's happened. Now if we jump over to GitHub and refresh, well, now it knows. There's the files, there's the README, there's my template. There we go. history. Hey, it knows all the history. It's got those hashes. I've got all of the different information. I can actually go and look at it. Oh, it shows me what was there. So it's now pushed all of this up to GitHub. I can see the differences. So I've really brought everything together now. And that's really all I have to do. Now notice one of the things I did was I kind of did this git push. Now the other option, what I could do is I could kind of set that remote as my upstream. So instead of just doing a get push, one of the things I could have done is -u to set the upstream of my environment. So now it's actually set to track that remote. So I do my get graph. Now it also knows that origin master. It has and can track that. I can do things like get remote, show origin, and it shows me all of the information about it. I could go and pull changes down. So if I actually change something up there, I could do a get pull. Now a get pull will kind of do a fetch, which gets the metadata and then a merge into my head branch, but I don't have anything at this point. I'm already up to date. So now we're integrated in. Now, whenever I make changes, every time I make a change, I'm going to have to push it back up. But I'm not going to worry about that yet. We're going to get to this in a second because I can merge two things into one from a demo perspective. I'm lazy that way. Now I want to do DevOps. So remember, DevOps is all about the idea that, hey, my deployments, I'm going to build that into my continuous integration, my continuous deployment. The whole point of continuous integration, CI, was about the fact that, well, I don't want to have these developers creating their code in isolation and then bringing it back together at some point in the future and it doesn't work. I want it continuously being brought in at the end of the day, automatically tested. So that's continuous integration. And that's where things like GitHub make that possible because they've got this shared repository. Then continuous deployment is, hey, I'm going to keep deploying. It's always ready to be deployed. I can test these things. And what's great about infrastructure as code is because it's that declarative, I want it to look this way, at the start of my deployment pipeline, I can just deploy the template. If it's already there, great. It's idempotent. I can redeploy it as many times as I want. It won't do anything if there's not a change, but it will make sure it's at that configuration. Now, GitHub Actions is kind of that pipeline capability to do things with GitHub. Now I need a service principal. This is going to let it use this in GitHub Actions to talk to Azure. So I'm going to store it as a secret in the repo. Now again, in the GitHub file for this repo, you can actually see I've got the command. So all I'm doing is an azad sp create for role-based access control, the name of the account I'm going to create, GitHub Actions. I'm going to make it a contributor of a certain resource group, sav dev GitHub deploy. Now it's going to spit out this big chunk of JSON. You're going to take that entire chunk of JSON and paste it into a new secret actually in GitHub. So let's jump over. So if I jump back to the portal over here, and we'll go and look. So I've got my project. And what I'm going to do is actually go to my settings. And then with my settings, what I can actually do is put in the required file. Now I saved that away already. And it's not that I don't trust everyone, but obviously I don't. Kidding, of course I trust you. No. I'm going to put this in. So here, under my settings, I have secrets, and I don't have one. So I'm going to create a new secret, and I'm going to call it Azure _ credentials. You can see it's kind of autofilling. It knows I created one of these before. And then I'm going to put in that entire chunk of JSON. So I saved that JSON. And actually, it's not, I'm just going to delete this straight after this demo anyway, so I'll just show you the whole thing. So I'm going to take the whole chunk of JSON, and I'm going to paste it in. So you can see I've got my client ID, my secret. So I'm just pasting in that whole thing and adding it as a secret. So now I've got this secret, which is the credential. Now, if I jumped over, if I go and look at Azure AD and look at my app registrations and look at all apps, there is that. So I can always go and delete this, which is exactly what I'm going to do once this course is finished. I will go and delete this so it becomes useless. But you can see for the resource group I'm going to do my testing on, if I can find, just going to look at all my resource groups. So if we scroll down, my sav dev GitHub deploy, that particular app service principal in my role assignments, there's GitHub Actions, I have contributor. So the whole point is it can deploy things to here. Okay, so with that done, we have a service principal GitHub can now use stored in a secret in GitHub. So now I want to do things. Now with GitHub Actions, it's basically a file, a YAML file. There's a whole bunch of these. If I go and look at Azure GitHub Actions, it walks through, and there's massive numbers of these things. I can really do anything I want. So if we go and look at, hopefully that opened somewhere. It didn't. So let's try that again. Kind of hit and miss sometimes. There we go. All right. So if we look at this in the documentation, I can see it talks through things I want to do. So I'm going to need to log in, an Azure login, and it's going to show me how to do that. The GitHub action for login is it's going to use Azure/login v1 with credentials secrets.azure_credentials, which is what mine is. And then it has an example of using run. Now, I'm not going to use run. Yes, I can. It's like sitting at the console and typing it. But what I find with run is you don't get very good error diagnostics back. And if you go and look at my GitHub Actions dedicated video, I'll show you an example of what you get. So what we're going to use instead is, there's actually, where am I? There's an AZ CLI command instead. Here we go with this Azure CLI v1. I basically just get better error checking back. So we're going to leverage that. So what I'm going to basically do then is, if I think about the flow, I'm going to use GitHub Actions. So I'm going to have to authenticate using the secret, check out my code, because it's going to create basically a disposable container to run these actions from. So it has to go and get the content of the repo. So I have to check it out. Then I'm going to deploy the template. So that's all I'm going to do. And then it could do other stuff. Now you might then deploy your custom application. There's a whole set of things you would probably do. So from here, what we're going to do is we need to obviously go and create this thing. So over here, if I go back to my GitHub, we're going to go to Actions. And we're going to create a new one. Now, there are samples. It's going to go and scan what you're doing and probably suggest better ones. For me, I'm just going to start with a blank one. And I say blank. It's putting in some basic stuff. It's going to save it to .github workflows main.yaml. I don't want it to be called main. I'm just going to say, I'll say deploy. And that's all I need. I'm going to leave it as it is and start the commit. Sure, I'll leave that. And it's going directly into the master branch. So now it's created that deploy file. So under my repo, there's now this .git workflows. Now, on my local machine, remember, oh, what's it doing? There we go. On my local machine, I know nothing about that. I'm not aware that this has happened at all. If I do my get graph, for example, oh, typed it wrong, get graph, I don't know it's moved forward. I don't know about the metadata that changed on that remote repo, because remember what I've done is I did a commit up here. So up here, I can kind of think about, well, I did another change. I created a hash kind of 4 where I've got that YAML file in it, but I don't know about that yet. I don't have that. I have to go and do a fetch and merge that into my main. or pull will do them both at the same time. So I need to do that before I know that even exists. So if we go back over to our code, that's what we'll do. So let's get my cursor back. This clears the screen. So we're good to go. So what I want to do is, now I'm going to do it in 2 steps. I'm going to do a get fetch origin. So that pulls the metadata down. So now I know that my origin master is actually ahead of me. It's kind of showing me that fact that, hey, it's a hash ahead. You don't have that. So what I would actually do is a get merge. So I could say, well, I can merge in that origin master. Now if I do a get graph, you can see I've moved forward. And as part of that merge, what's really cool is, once again, it did a fast forward. Because obviously it was based off of mine. I hadn't made any local changes. So it was able to just directly do that. So when I look at what it did, I can see it did that fast forward. So now I'm up to date. I know about that. Now I could have just run a get pull origin master, would have done exactly the same thing. But now I know about this. Now I've got that GitHub folder under my VS Code, and I've got my deploy YAML file. Now, before I do anything, remember I'm going to deploy to a new resource group, this savdev GitHub deploy. And if I look at it, it's empty. There's nothing there. So what I'm going to do is update that YAML file. Now, if you want to see the exact step-by-step every single thing you want to do, then you should kind of go and watch my other video where I go into detail on exactly what every step does. I type it all in manually. However, I'm not going to do that right now. So here I'm going to paste in one I made earlier. We can see it's on push. So anytime I do a push to the repository, it's going to execute this pipeline. I've given it a name. This can be anything. It's just Azure ARM deploy. Then I have a job. I've named it deploy, but again, it can be anything. I'm running on Ubuntu latest. This could be Windows, could be Mac OS. There's a whole set of different build pipelines it supports. Then I have a series of steps. I'm going to log into Azure. This name again can be anything, but I'm using the Azure/login v1 GitHub action. And I'm using the Azure credentials secret. Then I'm going to check out my source code using the GitHub Actions/checkout v2. Then I'm going to deploy an ARM template. I'm using the Azure CLI v1 GitHub action. And really I'm just doing the AZ deployment group create, so deploying a template to savdev GitHub deploy and the template file. It's based on the root folder, and then I'm using ARM templates. That's a subfolder I created. That's all I have to reference. So then I save that. And at this point, well, I need to push it up. So just like I do everything else, at this point, if I go and look at my status, if I can type git correctly, I can see there's files to add. So I'm just going to add them all. Then I'm going to do a git commit. Too many M's. Git commit -m updated deploy YAML file. And then I'm going to push it. Now remember, pushing it is actually what triggers it. So I'm going to do a get push origin, that remote origin to master. So that's pushing that up. So now if I quickly jump over, we're going to look at a few different things. So firstly, remember my resource group is empty. If I look at my GitHub and I refresh, well, I can see there was a push 28 seconds ago. If I look at my actions, it's actually running. Because it's on push, it's already triggered it. If I select it, I can see there's a job in progress. I can see it's setting up the job. It's currently logging into Azure. Then it's going to check out the source code. Then it's going to deploy the ARM template. So, okay, the checkout source code worked, the login was successful. Now it's running my script, and then it will do kind of the post cleanup when this successfully deploys. So we're looking good. So let's see exactly what it does. And the nice thing about the CLI, again, is it gives me good kind of diagnostics if randomly something doesn't work. Not that I'm expecting anything not to work. So it's going through. Oh, something didn't work. There's a shock. And if we look up, so I can go and see, GitHub deployed disallowed by policy. What? Allowed storage account SKUs. It shows me the policy that it failed on. Oh, I remember now. I forgot. I don't allow ZRS. Utter mistake. But you can kind of see the coolness here. It showed me as part of that, well, why didn't it work? So now all I have to do, if I go back to my source, we'll go back to our storage account, and I'll change this to LRS. Save it. Repeat all of those steps. Git add, git commit, updated for YAML file to LRS. I do a push. It's pushing it up again. Again, if we go back out of this, go to my actions, it started another one. My resource group is still empty, nothing got created yet. Now it's trying again. Again, it's automatically, that's the point of these actions, it's automatically deploying it again. So now it's logging into Azure again, it's going to check out the source code. And this time I'm really hoping it works. If it doesn't work this time, I'm kind of in trouble. But it's going to go through, and so I can see it's running the script. It's starting that execution. You can see it's actually saying the Docker image. So I can see it's using the Azure CLI Docker image based on that Ubuntu to actually run this thing. So let's go back. So that's deploying the ARM template, script execution via Docker image. Come on, fingers are crossed, toes are crossed. The only reason this might fail at this point is someone else stole my storage account name, which I actually had a problem earlier. I published these for other demos and someone took my name. So then storage accounts have to be globally unique. So then it failed. So please name your own storage account, your own resource group names. Don't steal mine. So it's still running, but it's still running is actually a fairly good sign. So I can see exactly the command it's running here. Feeling pretty good at this point. It probably would have failed by now. So it's going to create that storage account. And then what I'll see is it will actually show up eventually. Okay, so no errors. Post checkout, cleaning up, complete the job. So we are good, and we can see the update button. Let's go back through the whole history. And what we'll see is always takes a little bit of time, but there it is. There's my storage account, and it's that LRS. Now, just to kind of prove we'll put everything together, let's change it to a GRS. Remember, it's my desired end state. I'm going to save it. We're going to add it. We're going to commit it. Now we're changing it to GRS. And we're going to push. So remember, the whole point of this is it should work across anything. I'm just changing my desired state. It's going to be at the start of my deployment pipeline. So my resource is obviously there. It's LRS. If I look at it's already saying, hey, an updated deploy file to GRS. It knows it's happening. Once again, I can go and look at the details. So right now it's setting up the job. And what I would absolutely expect it to do now is go through that same sequence again. See the storage account already exists, but it's just using regular ARM at this point. My regular declarative, it should actually go through and update it. So I should see it change from LRS to GRS. So we can see it's going through all the various steps. Let's go and look in the detail. So that's doing the deploy ARM template. Exactly the same thing again. And what we would hope to see is it's going to do a switch. It sees, well, the storage account is there. It matches everything except the resiliency option. So I'll actually go and change that resiliency option to GRS. So I should just see that switch happening. And the point is, again, this is a super simple. Really, I'm not doing very much at all here. in my actual deploy file. But you could then have other actions that, hey, maybe I set up a Kubernetes cluster and then I deploy a YAML file to AKS that actually sets up my pods and my replica sets. I could set up really anything else. There's a whole set of things. I could compile my code. So this would be part of a greater pipeline that really does everything that I need. So that deploy is still running. Again, because it's updating the storage account, again, this is kind of a good sign. I think it's probably going to work. And what I should see at the end of this is my storage account should have flipped. So instead of being LRS, what we would hope, and actually try refresh, maybe it's done it. Oh, it's done it already. There we go. We can see it's GRS. So again, that declarative desire, so that is actually completed. It's just completing up, getting codes back. And that's kind of the whole point. So what we saw was a kind of a lot of different, and that's finished. So it says it's completed, it's all good and happy. We have another successful thing. So we went through really from kind of the start to finish. We thought about what is infrastructure as code. We had our ARM template, but we could, if we wanted to use Bicep to compile to that, other things like Terraform. Then we saw how we can use Git to change control, have the branches, the things we're working on, and then actually pushing that to a remote repository, and then actually triggering off of this with GitHub Actions. But again, I could have used Azure DevOps pipelines to actually then deploy it. And again, I would be that as part of a greater thing, maybe deploy my code. But we really today, I went through start to finish. We started with an empty folder. We made it a repository. We put a template, we created a template. We made changes. We integrated with the remote. And then we built a GitHub Actions, which the sum of all that work, because if it's an hour and a half or a 2-hour video, it's a long one as always, I ended up with a storage account. But you get the idea. Yes, I could have clicked 3 buttons and create the storage account in the portal, but that was just a simple example. Think about a greater pipeline, continuously deploying this between environments. This is super, super powerful. So it really comes to an end of right now the masterclass as part 11. I may add other parts in the future, but remember I create videos, multiple videos every week. I might update the GitHub with other videos that kind of link to it. I'll update as required. But please, please go and subscribe. Hit the little bell so you know when I post the new videos. Every week I do the weekly update. But as always, I appreciate you watching. I hope this is useful and you enjoyed it. Take care.